So another kind of a problem here, it's got a picture. Sometimes they'll give you a graph. They actually tell you what the coordinates of the points are. That's A, and that's B. Okay, and that's got a few things going on here. So it says, what are the coordinates of the midpoint? All right, well, midpoint is x1 plus x2, which is 0 plus 8 over 2, and then y1 plus y2 over 2, which is going to be 4, negative 1. So there's the midpoint. Then it says another line L2 intersects the axis at C is 0, 3, and it's parallel to L1. Find the gradient of L2. Well, the gradients have to be the same if they're parallel. So I'm going to have to find the gradient over here. So it's y2 minus y1. So I'm going to go 0 minus negative 2 over x2 minus x1. That is positive 2 over 8. You can reduce it if you want to. All right, I'll reduce it. It's 1/4. And again, you put that in the calculator as hit the alpha y equals and hit enter, it'll reduce it for you. So that's the gradient of L1. It's also the gradient of L2 because they have to be the same. So the gradient of that is 1/4. And then it says, find the equation of L2 giving your answer in the form of y equals mx plus c. Now, there's two ways to look at this, all right? I'm going to stick to the system I'm using all the other times. So the gradient is 1/4. The point is 0, 3. So I'm going to plug it into the point gradient formula, which is y minus y1, so y minus 3 equals m. Now, how about I plug the gradient in, equals m is 1/4 times x minus x1. All right, now this is going to be y minus 3 equals 1/4 x, because x minus 0 is x. It wants it in y equals form, so I'm going to add 3. So I get y equals 1/4 x plus 3. Now, if you know that form is the slope-intercept form, you could have just went right to there without that work. But I like to try to stick to doing the same thing each time and not having to memorize a lot of extra stuff. So I'm going to stick to doing it just like that. So there's not a lot going on in these initial problems here because they're fairly low level.